Hey, welcome to another edition of Math That Matters. Today we're going to do some really exciting stuff. You might remember from the very beginning lecture when we were learning about arguments, and we were wondering if arguments were valid or not. And we kind of just wormed our way through kind of this touchy-feely, didn't really do much math. But
we never proved if they were valid.
We didn't.
Yeah.
We said later on we're going to learn how to test whether or not arguments are valid, and we were just sort of guessing in lesson
That's
one.
right, yeah.
So today we're going to learn to test whether an argument is valid or not.
But I think we've kind of been doing that already, Pete. Haven't we done that? In other words, last class, you said, hey, if I sleep on my back, then I'm going to wake up. And we put that in a truth table. So I feel like we've already been proving arguments.
So is that an argument? If I sleep on my back, then I'm going to wake up? What did we say that an argument had to have? What are the key components to an argument? Do you remember?
Premises and a conclusion.
That seems like more than what you just said. What did you just say? You just gave me a statement.
I just gave you a statement.
You gave me an if-then statement.
Yeah.
That's one thing. It wasn't a bad thing.
Yeah.
It could be present in an argument, but it's certainly not a full argument.
Right.
So in order to take that and put it into an argument, you might say something like, if I sleep on my back, then I will wake up. That might be premise one. Then you could say, well, come over to my house, watch me sleep. You watch me sleep and you say, aha, I'm noticing he slept on his back all night. You have to conclude something now. There's something invisible that's present or implied in the information that you have.
To make it an argument, you have to have this conclusion.
Yeah. So you have said, if I sleep on my back, then I'll wake up. You look around, you say, he's sleeping on his back. What's your conclusion?
He's going to wake up.
He's going to wake up. Let's write it out.
Let's throw this one an example.
We'll write it out, and then we will test it with the truth table. So premise one.
Premise one, because we're testing arguments, and arguments have to have a premise. If I sleep on my back, then I wake up.
Sleep on my back.
Then wake up. So we have an if-then in our premise one.
Okay.
And this is a statement because it can be true or false. Premise two, I slept on my back.
Mm-hmm. Just a fact, right?
Also a statement because it's answerable by true or false.
Yep.
And an argument has to have premises and it has to have a conclusion. So here it is. Therefore.
Therefore. Now remember, we have this symbol that's 3 dots in a triangle, and that means therefore. So don't forget
it all the time.
Therefore, what was it?
I woke up.
I woke up.
This, as opposed to the statements we were testing with our truth tables, this is a full, complete argument with premises and conclusion. And you're telling me we can apply the tool of a truth table to the argument as well as we can to the statements.
And we can see that if when the premises are true, the conclusion always has to follow, then we will know it's a valid argument. So we can put that into a truth table.
So how do I build a truth table for an argument? What are the columns?
Okay, so the columns are premise one, premise two, and conclusion. Do you want to build it?
I'll go for it.
Go ahead.
Okay. So I have to have a column for premise one.
Yeah, and let's give it some letters. So if I sleep on my back, then I will wake up.
Good. And notice I'm labeling my columns premise one and premise two because to make a truth table for an argument, you've got to have your premises. Okay?
Yeah, so if I sleep on my back, then I will wake up. I slept on my back. Therefore, I woke up. Really simple. Premise one, premise two.
And that's a logical form that we'll end up using a little bit later, so take note of that. But in general, to draw your attention to this, our truth tables are going to be made up of premise columns followed by a conclusion column every time.
Yeah,
and now you can fill these in. So go ahead, fill in. Pete, what's premise one in terms of symbols?
S goes to W.
If I sleep on my back, I wake up. What's premise two?
S.
Good. I slept on my back. And what's the conclusion?
W.
Excellent. So every time you'll have your premises and conclusions here. All right, I'm ready now. A truth table. What do I do, Pete?
Yeah, well, we have 2 atomic statements. That's all. We have got sleep on my back, and we've got wake up. We've only got 2 letters. So
I feel like we built a truth table for this last class.
We did. And now that's only a part of the truth table.
Yeah.
But really, the 2 letters that we're using are S and W. Now, would you be more comfortable putting another column of S and W over here, since they sort of seem like the very first things we always put down?
I think we should backfill. I think we should remind ourselves. Can you erase that for me a little bit?
I'll give you space.
I think we'll remind ourselves, if we're going to need an S and a W to fill out this column, I'm going to build columns of S and W there.
Okay.
And here's where I'm going to put in my true, true, false, false.
Yeah, okay. So they could both be true. True, false. False, true. Or
that's
false,
the 4
false.
possible iterations, right?
Yeah.
Now we're pretty good at filling this out.
Yeah.
Go ahead. How do you
Easy
do
enough.
that?
I say the only time a conditional is false is when I have a true false pair.
That's right.
TF. I'm looking for, oh, there's my TF.
That's it. That's the
so
false.
W is not following S. That makes this untrue. So this is the false. And all the others are true. Don't even have to think about it.
And this is a repeat of what we've done already. We got there. Now, how about filling this column out?
You know, you actually don't need these two, but we put them there for familiarity so that you'd be comfortable. It's a new thing. But this is S and this is S, so it's really exactly the same
Just
thing
copy
as
it
over
over.
here. Yeah. So you don't even need this, but we might as well. It doesn't hurt.
Yeah, I think it's helpful. And the
W
same with
is
W.
TF, TF.
So in this case, we could have built this without backfilling, but it just helped us to
that's
see
okay.
that these two led to this. I guess we want to distinguish here that whereas this was fundamental or foundational as a building block in the past, now it's one of your premises.
Yeah, and that's okay.
Okay, so I've got my truth table built, and I've got 2 premises and a conclusion.
Yeah.
How do I use this to figure something out?
Here's the definition of a valid argument. If, when the premises are true, the conclusion is always true, then it is valid. So I'm looking for where the premises are true. That's called a critical row.
I'm going to, at this point, just erase this because it was just for temporary purpose to build
that's
this
fine.
out. And I want you to focus here.
My premises are both true. My premises are not both true. My premises are not both true. And my premises are not both true. So the only critical row in this argument is this one. And you don't even have to worry about the other rows. Critical.
So a critical row is defined as a row when your premises are true.
And none of these are critical rows. So I can kind of, I mean, I needed them because I needed to know they didn't work. That's information that's useful. But in order for this argument to be valid, every time the premises are true, the conclusion must be true.
Excellent.
And it is.
And we'll see examples in the future where we have a couple trues here and a false, and we'll see what that means.
So this is a valid argument. And actually, there's a name for this one. It's so popular. I mean, think about this. If S, then W, S is true, therefore W
Seems
must
kind of
follow.
obvious.
It's saying there is a cause and effect relationship where the cause is present, which means the effect is present. This is called, in Latin, modus ponens.
Give it to us. That
Yeah,
sounds
modus
cool.
ponens. I'll write it over here. And we just like to sound cool.
We're going to cover about 6 rules in all, only a couple today. 6 of these logical rules, right? This is one of them.
Yeah, and actually modus ponens just means the method of affirming. Method of affirming. So if you wanted to, you could call it affirming. It's just a named argument that is used so often.
Good.
And so if I want to give you the rule, which is really important, you got to know this one. This is the most popular one out of all of them.
Number 1.
We would say premise 1 is if P, then Q. Premise 2 would be P is true, and the conclusion is, therefore, Q must also be true. That's it.
Anytime you can build an argument with a conditional statement first, followed by a premise where the
Antecedent.
antecedent is true,
Yeah.
you then have the conclusion is true.
Yeah, we're affirming that the consequent happens because the antecedent is present.
Love it.
Fancy words, but it's
Now in the future, when I get this situation, I can just say modus ponens, that's it.
Right, you don't have to do this again. We've actually just proved that this method is a valid argument form, and so you can just kind of jump over this hoop into a structure that matches.
So I can read that and say, hey, you got modus ponens, that's true.
Yep.
Right there. Beautiful.
Perfect.
Let's do another one.
Okay, here's our second example. And you tell me, we'll just play this like with our intuition first, and then we'll test it.
Good.
So,
I like that.
So we'll play this game.
You got to play along too.
If it is raining, then the ground is wet.
Okay, that's a truth.
So we could say, if it is raining, then the ground is wet. That's premise 1. Premise 2, it is not raining. Therefore, I must conclude the ground is wet. That's the conclusion.
When you say I must conclude, you're not sure this is a valid argument. That's what we're testing.
Right, yeah. So I just think, is this good thinking or not?
Okay, let me think. If it's raining, the ground is wet. I go outside, it's not raining, and I conclude, therefore the ground's not wet.
Yeah. Is there any other way, or does the ground have to be wet?
This is a tough one. Test your intuition. Oh, man, I don't know. I feel like I need to test this. I feel like I'm getting tricked right now.
Okay, well, let's test it.
All right.
So let's put our premises.
Here we go. You got it. Premise 1.
R goes to W.
If it is raining, then it is wet. That's a given. Premise 2.
It's not raining.
Not raining.
So, it says not wet. I should have put a not right there.
Yeah.
Yeah, therefore, the ground is not wet.
And I'm going to propose that we take a jump now. We've done so many of these. We kind of know that the second line has been false. And there's been truths here, here, and here. Is that
as long as we keep the same pattern of choices.
So maybe we should backfill that, Pete. I'm talking to you.
That's okay.
Now. I don't know.
I don't mind that. I mean, if you find a little trick that kind of works for you, there's nothing wrong with that. So. And you found a trick. So
we kind of skipped ahead here. If you need to rewind, you can go look at the last example, and you'll come to this conclusion. If you need to backfill with a column for R and W, that's okay to lead to this conclusion. All right?
Yeah, so we just need to know every possible scenario about raining and the ground being wet and the true-false patterns.
I'm actually changing my mind. I'm going in real quick now just because I'm going to need the R's. We need a not R here.
Yeah.
So a not R is the reversal of the R's. So what do we get there? 2 falses and 2 trues. Just flipping these. True, false, true, false.
False, true, false, false.
Okay, now we need a not W.
So change those.
Yep.
False, true, false, true.
Whoops, W. I'm really losing it.
It's okay, it's going well.
Things are going bad. False, true.
We probably need bloopers, right?
False, true, why not? Okay, that's a little T. That's kind of a squatty T. Okay.
It's okay.
All right, now what, Pete? I'm trying to prove this argument.
This is a tool. Our tool gives us every possible scenario for the particular argument.
Very similar to the last one with 2 premises and a conclusion, a little bit of backfill to get to the premises and conclusion.
Yeah, so we have to find our critical row or critical rows. Sometimes there's more than one, and that's where all the premises are true.
Okay, I see 2 critical rows.
Yeah, so both of these are critical rows.
Now before you go there, is this valid if one of these is true or if both of these is true, Pete?
That's the thing, is that with a valid argument, every time the premises are true, the conclusion must be present. And so every critical row has to have a true conclusion.
Gotcha.
What does that mean about this argument?
Problem.
We have a problem.
Yeah.
There is a way that the conclusion is present, but there's another way, another real scenario where it might not be true.
Now, can we go back and figure that out? What was the falsity that I missed?
Yeah.
If it's raining, the ground is wet. So I say, okay, that's a true statement. It's raining and the ground is wet. I also go outside, it's not raining. That's also true. But then I go out and I feel the ground, and the ground's actually wet.
Yeah, and you think...
So this was false. The ground is not wet is false.
Yeah, what I did was I took what was called the inverse of this statement, and I kind of applied it as though they were the same thing.
And now actually it makes sense to me because that could be, oh yeah, the sprinklers went on.
Yeah.
Right?
But yeah, it's not raining, the sprinklers are on, and the ground is wet.
So this was still true, and this was true, but this was false.
Right. This is just the invisible truth that has to be present, but it doesn't have to be present. And
what's beautiful again is though I couldn't really think my way through this that clearly. Rock solid.
The test, yeah.
Yeah.
What'd
you call it again? Fermat's theorem?
Well, Fermat's theorem is a different thing, but Fermat's quote was...
that's what I meant.
Yeah, a great argument compels belief. Like you have no choice. Inside, you're so convinced that it has become something that you can't even argue with yourself on.
And this critical row convinces me that that is an invalid argument.
Yeah. So if, when you have a critical row, there's even one conclusion that is false, that shows that the argument is invalid.
Man, I wish I had this when my kids were young. I would have been just pounding them with this stuff, man.
This is how I should have raised my children, too. Think of all the trouble we would have kept ourselves from.
Okay, this is so much fun. Can we do another one?
Let's do one more.
All right, one more. Okay, I got a blank truth table ready for a couple premises and conclusion. Now, Pete, we could have more than 2 premises, right?
We can have lots of them.
Okay.
Or you can have one.
All right, but not today.
Not today. Today we've got 2 premises and a conclusion. So here it is. If I study, then I get an A.
I feel like I can fill that in right now.
Okay, do
I
it.
need some letters, though.
Do it,
I need
yeah.
some letters.
So if I study, then I get an A.
Got it.
Premise 1.
If, then. Okay?
I didn't get an A. Now, a lot of times people will choose another letter for this, but it's not. This is the opposite of what you've already talked about.
Yeah.
So make sure you don't pick another letter.
Because A is I got an A.
Yeah.
So this is
so
not
I did not
A.
get an A.
Premise
That's
2
premise
is I did not
2.
get an A.
And the conclusion is, therefore, I didn't study. That would be not S.
Not S. So should we do kind of the intuition test again? What do you guys think? Does this seem valid to you? Not sound, but valid.
Yeah, it does seem valid because if I think about it, like if I'm saying that getting an A follows studying, but it didn't happen, then I couldn't have studied because if I had, I would have gotten an A.
Yeah,
Does that make sense?
I would almost bet my kid on this one, but I need this to make the
Would
bet
you bet
sure.
your kid like I could have him?
Yeah, like I'll bet my firstborn son. But no, with the truth table, I'll make the bet.
Okay, with the truth table.
I need the truth table. So
Okay, so let's do it.
we got a backfill, like always.
We got S, we got A.
True, true, false, false, true, false, true, false. Get good at doing that. Okay, here we go.
Oh.
I've gotten good at this one, Pete.
Yeah.
True, false. I don't like that one. That's
Nope.
the lie, right? That means these guys are true. Did I do it correctly?
Yeah, perfect.
Okay.
Turn those around for not A.
False, true, false, true. Got it.
Turn these around for not S.
False, false, true, true. Man, I'm just like a robot. I
Perfect.
love this.
Oh man, you're getting so
Okay,
good.
here we go.
Critical rows, where the premises are true. Nope.
No, no,
Nope.
no. Yes.
One
Oh,
critical
I looked
row.
ahead. I got excited. I couldn't help it. Yeah.
There it is.
Okay.
It's a good day, right?
That is a good day.
You
which
kept your
tells me
firstborn son.
I get to keep him. Now I will bet now. I didn't bet earlier. Now I'll bet you. Yeah. So that's a valid argument.
It is a valid argument.
Okay.
In fact, it's so good that it's like our second most popular argument. It has a name too. It has a Latin name. And this one is called modus tollens.
You got it, Pete. Number 2. Give it to us.
Modus.
All these fancy names. Can
I
we just
know.
call them, can we give them animal names?
Yeah.
Like I want to call the last one an elephant.
An elephant, and this one's a giraffe.
Yeah.
Yeah. Call it whatever you want. I don't
Okay.
care.
On the test, can I say by giraffe?
by giraffe? As long as you define
At
giraffe.
the top,
to
if
be
you say
modus
giraffe
tollens.
is modus tollens. Okay.
There you go.
All right.
So
But
modus tollens
The other
says,
one was the affirming. What's
yeah,
this one called?
This is called the method of denying.
Okay.
So we'll say that too.
Okay.
I think if you wanted to call it denying,
I'm thinking that tollens means denying in Latin.
yeah.
I'm pretty good at translating.
You're
see?
pretty smart.
Modus must mean method.
That's why you still got your first kid. Otherwise, you wouldn't have him because you seem to be a betting man.
Yeah. See, I'm good at translating languages if you just line them up right under each other. Okay.
So premise 1, here we go. If P, then Q.
Okay.
Premise 2 is
Not Q.
Q didn't happen. Therefore, our conclusion is P couldn't have happened, right?
No way.
Because if it had, then Q would have followed. Modus tollens.
And if I see this in the context of a larger argument, I say boom.
We know
modus
it's true.
tollens, it's true.
If you want to argue like that, you can do it all day because we verified it with the truth table.
Okay. And again, we have a total of 6 of these.
Yes.
What do you call these, Pete? What do you call this collection of 6?
These are called valid argument forms.
Okay. And so far we've given you 2, modus ponens and modus tollens.
Yeah.
And we're going to unpack another 4
Yeah, you're
in the
going to
future.
probably test one of them in the take-home quizzes, and then
That's
we'll
right.
give you some more.
But these are the 2 big dogs.
Yep.
So I think that's it for this one. You should
it.
be set for your THQ exercises, and we'll look forward to seeing you next class.
Absolutely.